Greetings again, YouTube. I wanted to take a quick look at a part that I saw on YouTube. Titans of CNC was machining this cube, and I thought it was interesting the way he went after it. And well, I actually saw a few things that I would do differently, and I was just curious how it might come out. So hop along for the ride. This is the first I am looking at this file. So you can go to his site, academy.titansofcnc.com, and start looking up files. Give him your email, and you can start downloading stuff. Here's the download link from Autodesk. So it's a cube, eagles, and it's got some text on either side. So it's symmetric this way, and it's a circular pattern around this way. So I'll click download. I'm going to grab the Fusion 360 so that I have access to the file. Let me just type that in. Oh yeah, that's how. Okay, hang on a second. Okay, so we went through the process, got the file downloaded. We're set to open it from downloads here. Click upload. I'll pause. Okay, it says complete. Close that and open the file. And I don't know if this is going to have any tool library or any CAM associated with it at all. Yeah, no setups, nothing. It's fresh. That's perfect. Also, I think I'll take a look and see how this is set up in the model environment as far as where our origin is. And good, it's where I want it to be. So, yeah, take a look at how I would set that up in CAM. So what he had was round stock, and I would probably pull it out of something similar. I might be able to find some square stuff to put in a vise. Click new setup, and then we say our stock is fixed size box, and I have mine set to round up to 0, and we're in millimeters here, so I'm just going to hit OK. And I like to toggle that over because all my tooling and stock material is inches, so I will continue to default to inches until I start getting millimeter material and tools. Let's see here. Edit, and then we look at this stock. Okay, so I see that the width X and Y is 2.075, but it's not a fixed size box. This box is going to be a fixed size cylinder. So I have it to round up to nothing. I'm just going to tell it 3 inches because that's pretty nominal. Actually 3.03 because that stuff's almost always oversized. Additional stock, let's give it, let's see, length, we're going to say that it is, let's just say we got 6 inches in there. Nah, not that much. Let's say 4.5. That's probably what I would cut it at. All that subject to change. We would also probably include a chuck or wherever we're holding, you know, so we can verify that our tool holders aren't going to smack anything. So model position offset from front. Oh, and I've already screwed up. I should have set up my yeah. And then stock. I'm going to choose the axis, and I'm going to choose this axis right here. Actually, I'm going to choose this axis, and then Z is going to live up here. What I'm getting to is, gotta change my stopbox point here. What I'm getting to is this is a circular pattern, so like he did in the video, that's going to be a circular pattern as well. This is the unique geometry, so we'll throw that on the top. Oh, what else? Stock is good. 3, gave it a little extra, 3 30/30. 4.5. Oh yeah, offset from front. I'm going to say offset 30 thou from the front, and then set up. I like to be model box point because I think that the coordinate system should match where the part physically is. That way, if you want to re-pick it up halfway through machining, you got that option. So that's just how I set up. Or if you probe the stock here, it'll automatically put the part 30 thousandths inside of what you probed. If you're doing that kind of a setup. So that's ready to go. So the first thing we did was, or he did in the video, was to deck the top off, and that's exactly what I'm going to do. So, but I'm just going to choose 2D contour, and this was done as well. Select a single line right here. We're going to flip that around, and then we're going to say tangential extension of 1 1/4, and then we're going to say stock to leave. Give it a radial stock to leave of minus 0.25. And make sure that this is tied. You can click edit expression. If you click reset to built-in default, click edit expression, it looks up at the stock to leave. Now I've changed this several times, and it seems to want to get changed back. I almost always manipulate these two values independently. Very rarely is the radial and axial stock to leave 1 to 1. A lot of times one is 0 and the other one is like positive 1 or something like that. So what I'm going to do is set this to 0. This is just making it its own independent number, and then I'm going to say make default. So within the 2D contour, it's going to kind of delink these two fields so that I can type minus whatever I want there. So it's giving me an error here because it sees that that's bigger than the tool diameter because we haven't selected a tool. So let's pop in here and select a tool. Now I don't actually use a lot of face mills, but I think there's some in the tutorial here. Yeah, 2-inch face mill. Yeah, I might have to increase the size of that, but we'll say yeah for now. All right. We're going to delete these guys. Lead in, lead out. This is one of those examples where once you get a cycle tuned up the way I'm going to have here, it would be worth leaving it that way and storing it. You can right click and store it as a template and just throw it on your desktop or somewhere safe in a folder, and then you can place from a template later and not have to do all this stuff. So yeah, I want to edit this tool real quick. So I'm going to say double click to edit tool, cutter, corner radius 30 thousandths, just to make sure we understand that it is a face mill. A lot of times they have mine generally no bigger than a 30 thousandths radius, but the main thing is the diameter. We're going to say that's a 3-inch, and then yeah, we'll call it that for now. I'm not going to mess around with the holder. You guys know how that works, or the speeds and feeds. I'm just going to say yeah to it. I got here, generate this toolpath, simulate, and turn the stock on. Now, of course, this is entirely too much, right? Completely too much for that tool. So we're going to say edit, and then do multiple depths, and then we're going to say depths of 0.1 is fine for now. So that's not super quick, but it will do a good job. Let me make sure I'm not. Yeah, the first one does. Yeah, look at that, perfect. I don't know. Yeah, there's not a good way to trim for stock contours when the circle's in this direction. So that's facing off of a contour. If we turn the stock transparent, we can get an idea of just how much more. We've got enough there. I may add a little bit more. If there's a 3-inch, yeah, I'm gonna make that 3/8 so that I can sneak down here and kind of slot a little bit with a 1/4-inch end mill. But we'll get there in a minute. We go ahead and just change that stock to leave minus 2.5 is 0.375. Okay, right click and click add to new pattern, and then we choose that it's a circular pattern, 4 instances, and the axis is going to be this Y model axis. So that's pretty good. With this, I might shorten up. No, I think it's fine. It's going to be cutting a little bit of air, but this is going to happen fast enough that it's beside the point. It's totally good. Okay. And I had some ideas about how to knock those chamfers in that I thought of, but I'm not sure if it's worth pursuing. We'll try a couple different options here. Okay, so we've got that. We also need to move it this way. You know, I wonder if I can. Oh, I bet I can. Duplicate. Let's just drag this out of here. Let's see if this is Z normal. Try this. Tool orientation. Z is up here. Delete that. And I'm programming this the way that my 5-axis tilts. It's a trunnion that uses the A and C axis, whereas like a UMC is gonna be 90 degrees to that. So this is gonna look a little bit weird if you're used to programming for a UMC, but this would match what I would do on mine. So that's that way, and then this would be, yeah, that would be first tilted down. That's actually not right. Man, I screwed up big time. Box point here. Yeah, that's actually how I need to start out. So we can hit Control, generate. That's happy. And then in this case, we're going to use tool orientation. This part. We're going to say Z's up this one. Yeah. So what we have is we have an initial setup that's like this, Z vertical from our setup. Then the stock leans forward, and we can reach these instances here, and it's just going to rotate the C axis. So yeah, that faces everything. Go ahead. I don't mind. I played through simulation about 30 times before I run apart. Okay, so we have a cube. Easy enough. The next thing I want to do is to knock a chamfer on real quick. And so what occurred to me that I wanted to do was click 2D contour here. I'm bad at I like using 2D contour over the chamfer toolpath. It's preferred. The chamfer is really cool when you have avoidance and shoulders to miss, but for some reason it just wants to do weird things. So for me sometimes, so I go to contour by default. So we'll go back to the tutorial and look for a chamfer tool. There's a chamfer mill. Yeah, we'll just say OK to that. And then we'll say chamfer width is 0 because the chamfer is already modeled. But the tip offset, I like to get the surface footage up, meaning I like to work on the larger diameter. So I think that was a 1/2 inch. I'll say, no, not that much. Let's see if 250 isn't crazy. Just turn the stock off here. Oh yeah, that's completely wrong. But it does follow the angle there. Not what I wanted. My bad. But I want to get up on that top corner. There's a way you can do this with an expression. Smarter people than me do that all the time. I'll do that sometimes. And then quickly forget how to do it. Simulate. There we go. That's good enough for me. We don't need to be right at the absolute tip of this cutter. I have a cutter that I use at work all the time. Also, yeah, I totally agree. Let's lead in on a better point here. So I would say under the linking tab, entry position, I want it to lead in right there. And absolutely, we can get it to do that. So we got a nice lead in. And then we're going to go back up to this pattern. We're going to click the little, I guess there's a radio button here. Make it our default so that whenever we when we do work, we can everything will happen and it'll automatically be inside of that pattern. We won't have to drag it. So because this has tool orientation already set, I'm going to click create derived operation, 2D milling, again 2D contour. So we have 2D contour. Oh, one issue here. This was actually already active. Yeah, there it is. It wasn't dropping inside that pattern. So basically, we could have just hit duplicate. I try my best to break things. All right, so here's our pattern. What do we have in it? We've got a contour and we've got another contour. Because I said create derived operation, really it just duplicated it. That's what I should have done in the first place. Both of these are inside of the circular pattern. So I'm going to change this second one to be a chamfer. Now why did I duplicate all that? Well, to save me from clicking the tool orientation button. So it wasn't really necessarily a win. Let's edit this. We'll select our tool and we're going to tell it we want this chamfer mill. Now the thing to look at is, well, what actually needs to be chamfered? And it's really not a lot because we've already chamfered this top face. So all that we really need to do, and I'll hold Alt here and select this geometry. Oh, this is already selected, so I'm going to actually Control deselect that. Double click this guy. We're making an open contour here and there. So when we cut that L and we make a pattern of 4, it's going to come around. The last thing it cuts is this one here. So make sure we have the same 0 stock to leave. Tip offset 150 is what I did before. Yeah, I should have totally just duplicated the chamfer off and thrown it up into this pattern here. So here's our pattern. Yeah, definitely should have just duplicated my chamfer off. No sweat. Back on track here shortly. Open contour and click the green plus sign. You'll look and see that's what I missed earlier. Okay, so we're starting a little bit beyond the part here, a little beyond the part over there. Let's just simulate and see what things look like. So the stock's on. I'm actually going to turn the model visibility off so I can see better what's going on. Into that operation, into that operation. This is all just wash, rinse, repeat. That chamfer mill is going to see less material in the actual part here. I'll show you in a minute. Turn the toolpath visibility off. Okay, so we got chamfers on every surface, but I want to get this a little bit nicer to send a chamfer tool through. So I'm going to say for this operation, I'm going to duplicate it like I didn't do last time. Turn the model visibility back on. I'm going to edit it, and I'm going to look at the contour, close that out, and then I'm going to select just this line, and then extension of 5, half an inch, and then I'm going to actually give it some, it's not a chamfer, stock to leave, radial stock to leave, 15 thousandths. What that's going to do is this face is going to happen in another machine, in another setup, so I want to stay off that material. But it's an excellent place to help me guide a rough saw cut and pull a little bit of material out of there. So for the heights, I'm going to say the bottom is the selected contour minus 0.25, because if the tip offset is 150, 250 is a good number to go beyond. And I'm actually going to go ahead and say multiple depths. So not roughing passes, but multiple depths here. Where's my multiple depths? It's because it thinks that it's a chamfer. That's why. I could not figure out. So let's go back and select a tool. Let's look in tutorial again. Quarter-inch flat. Click OK. And now, now we can get into multiple depths. Maximum roughing step down. So it actually eliminates this field entirely when you're using a chamfer tool. Threw me off for a second there. I either didn't know or completely forgot about that. And then the starting height, we've already decked all this stuff, so I'm actually going to say that the top height is going to be the model top. And one of the last things I'll go through and do before I actually send this program to a machine is I'm going to check all the heights and make sure they're in a reasonable and safe place. Now, my post processor right now sends the Z to G53Z0 before indexing a move. So I'm more comfortable with these tabs because I know that the post processor is going to send me up to Z0 up there. Okay, so if we simulate just this, we need to change the order. Facing, knocking a little slot in there, and then running a quick chamfer. So now it's just the engraving. And one of the things that I wanted to try, and I would use a tool similar to this. In fact, I'm going to modify this tool really quick to be more like one that I've actually got in my machine. It doesn't let you edit the tool right-clicking here, but if you double-click, you can totally get in and edit the tool. This is a 4-flute tool. The cutter is 45 degree. The tip diameter is about 15 thousandths, 15 to 20. And the shaft diameter is ½ inch as well. So, and that's roughly equivalent to the SK type holder that I would have it in. What else do I want to see? We'll click OK to that. Generate these two toolpaths here. Everything should come back pretty happily here. Turn the stock off because I don't care about the stock. I want to see what this step down is doing relative to the model. That's pretty good. We're not down at the tip where there's no surface footage, but we're not, at risk of leaving a little step or anything. So that looks pretty good. I want to see if I can use, because I saw what Titan was doing was just using the trace operation to put the engraving right on the center line. I'm curious if maybe I can do something a little bit different. And I kind of want this eagle to be a little bit bigger. So let's leverage the model part of things here. Origin. That's interesting. I don't have any history on this. I wonder if you just delete this. Okay, yeah, so we can delete that directly off the face. Oh, weird. I want to delete all but one. Control here. There are people who are much more professional at selecting stuff like this. All faces, okay. So that's deleted directly. Then what I'm interested in doing is seeing if maybe I can select every bit of this. M for move, and then I want to rotate this. Did that do anything crazy? I don't see that it did anything crazy. Move it to about here. I'm not going to try and tie it down to any geometry or anything. Well, I screwed that one up. We got just that, yeah. M for move. N for move, bodies, faces. What happens if I just click that? I mean, that's pretty cool, but that's not what I want to do. I want to just rotate that stuff. Yeah, it's not going to do it for me. Well, that's a little bit annoying. What? So you can't get it outside of that. That's really weird. But it's fun to be able to do stuff like this. I don't really spend any time in direct modeling here. Direct edit. I like my parametric timeline. Click OK. And I think I can scale this. If I select just that, hit S for the scale. I want to select an entity. I want to select just this stuff. So that's something I'm not really able to do without timeline. Like if I just had the sketch, I could just do that. So maybe that's not what I want to do. Cancel. Yeah, let's just live with it. It'll be small. Maybe I'll make it my own little. I was hoping to make it big enough that I could cram that normal size chamfer tool in there as my engraving cutter. No sweat. "38 faces selected," and then our axis will be this axis. I'm going to have it 4 places. Click OK. And it's going to think, okay, cool, we've got little crooked eagles now to make it my own. Back into Cam, now you'll see everything is completely angry at me. It's fine. Generate, and it comes right back. So what I want to look at now is some of our 2D operations. I want to see what happens when I choose engrave. And I've still got this 90-degree cutter. In fact, normally I would just select, you can actually select just the sketch that this is made from. But because these exist as model, there's no sketch behind it because I don't think there's any sketch anymore. Let me just grab this guy for now and hit OK. It's starting to do it. I didn't look at the sketches here. Yeah, there's no sketches available. It's literally just a solid model brought right in. So back over to Cam here, engrave, and then most of these are a single loop though, so that won't be too much trouble. If you ever accidentally select, just control and if you ever select like a segment of geometry where you wanted to loop, just control and click and you can deselect it. Okay. So you can see most of the toolpath is invisible. It actually leads in and disappears. That's good. It's doing what we want it to do because I've told it basically look at this inside and outside boundary and fill it in. And so what these blue lines are is just dragging the tool up vertically to use just the tip of the tool and get a nice crisp corner. Whereas if you used even a tiny like a 30-second end mill or 1 millimeter end mill, you'd still see a visible radius there, and it would look just not as good. So if I go to simulate real quick, and what I want to do is turn the stock, I need that facing up, and then control to select just these two, because that's all I want to simulate. And then go into simulate, and then I want to turn this model visibility off, because I want to see how the part looks. This is what we're actually going to be getting out there at the machine. Okay, so the O got weird. Let's look at that. Oh, I know exactly why that happened, because it's a concentric circle that's not. Yeah. So we'll edit this. Look at our contour selections. Yep, totally. Forgot to select that inside loop. So once again, grab just our facing op and this final engraving op here. Blast through that. So you can see the model showing through, but you can see what's going on, but it doesn't really tell the true tale of what the engraved part's going to look like. I kind of like that. I don't get a chance to do a lot of this stuff. If you want it to look really good and keep the tool pressure off, one of the things that I like to do is multiple depths here. I thought I could do that. That's weird. Well, one of the things you could do would be to well, there's some funny business you can do, but you can put that into a linear pattern or something and leave it 5 thousandths high, so it does almost all the cutting, and then the finished pass is just that, just a finished pass. The other thing I want to do is edit this cycle because we're using just the tip of that tool. I would go ahead and give it like most of what the machine is able to do in terms of RPM. And the feed rate per tooth, 8/10, 5/10. That's how I would probably engrave it. I might rough it with a quicker engraving cycle here. But anyway, let's copy this. We're going to paste it into the pattern, and then we're going to edit it, and then let's turn the model back on. Let's enable some tool orientation. So if this is the initial, I'm going to roll it this way, clear off this entire selection of chains. Then I'm going to choose for geometry, doing some weird business with the closed loops here, but that's okay. We're going to grab that. Oh, I know exactly why. We haven't clicked tool orientation yet. Tool orientation. This face is now Z. Let's see if that does a better job at giving our contour. Yeah, contour selection is a lot better. And I don't know if it's going to be able to drop anything in there. Actually, that's most of what I was worried about. So we'll look. If I can't get it with this same tool, we'll make like a really pointy, like a 60-degree engraver, which I've got a few of those, but it's trying to do something. Let's see what that looks like. In this case, I'll just simulate the whole business to make sure that the stock's removed. full setup. That's what I meant to click here. Simulate. But now you can see the slotting that I was doing ahead of time there. And that's just to make life easier. I forgot to simulate and kind of show that before. So I made sure we're climb cutting against the part. That way if we were to cut like to the part's final dimension, it would still be a decent finish. When you're slotting, it's really irrelevant. Okay, we still get a little bit of a gouge there. I can deal with that. So the model visibility is on. Let's turn it off. I like that. That's like a nice deep groove, and it gets all these nice facets and corners in there. It kind of adds to the whole stealth look of the bird anyhow. So you saw that I just programmed the one side. Since the pattern already existed and I set my operation inside of it, it automatically set things up. So yeah, that's how I would program Titan's cool little cube there. I didn't really play with feeds and speeds. I grabbed stuff out of the tutorial, but it says that it takes 10.5 minutes. Could probably make it happen in about 5 minutes, even on below VF2. So thanks for taking a look. I hope that was worth watching. Not really good at making these videos, but I do enjoy the CAM environment of Fusion 360 and Inventor HSM. So as I learned cool things, I'm excited to share them with people. So click thumbs up. Let me know what you think. Hope to make some more of these and maybe show you some stuff that you just haven't seen yet. Thanks for taking a look.